And we're doing our polynomial vocabulary. So it says answer the questions about the following polynomials. So the polynomial we're looking at, we have a 3x to the third plus 1. And in lesson 11, on the second page of our notes, right at the top, we had a table where we filled in all the degrees of polynomials, and then we filled in the number of terms and what those terms are called. So if you have not done lesson 11 yet, you can go back and fill that in. Our notes are always available. All right, so first we have to name it by its degree. The degree is this little exponent right here. So our degree is going to be a third, which is a cubic. So think like three-dimensional cubes. So cubic is going to be our degree. Our terms are split up by these addition and subtraction signs. So we have a 3x to the third plus 1. There's two separate terms that are split by that one addition sign. So our number of terms is 2. The constant term is the number without the variables. That would be a 1. If it was a minus 1, like a subtract 1, then I would use a negative to show that. The leading term is the term with the highest degree, which is that 3x to the third. So I'm going to hit 3 and then x. And then I'm going to hit shift 6 to get my exponent. So 3x to the third is the leading term. And the leading coefficient is 3. So there is our answers for that one. We'll hit submit. Yes. And there's our completed problem. So I will go and check after our session here today, and if you have your 1 out of 2 on that section, then you are good to go for that one. Yes, Morgan. You're gonna hit shift, and then the number 6 has that little like kind of triangle. That's your power key. So shift 6. Leading coefficient was 3. So it's the number in front of your variable with the highest degree. So we had x to the third. The coefficients are the numbers in front of your variable. So that 3 would be my leading coefficient. So I already did my 2, but we can do one more and show this next one. So the next problem, we've got a negative 1/9 plus x squared. Now x squared is my highest degree, so that's going to be that how I determine my polynomial. So second degree is quadratic. The number of terms is going to be 2. I got the negative 1/9 and I got the x squared. The constant term is going to be negative 1/9. And I'm going to hit the backslash, which is right next to shift, to make a fraction. So negative 1/9. Leading term is going to be my highest degree. So that's going to be the term with x squared. So I just hit x, shift 6 squared. And then my leading coefficient, since there's no number in front of that x squared, I'm just going to put a 1 there. So there would be my answer. And there I've got that problem completed. So if you do 1 out of 2 there, then I will mark you down at the end of our session. All of you that are present, I'll go in and check, and then you'll get your ½ point extra credit. All right, we ready to move on to the next one? I guess I can't see all your faces right now, but we'll move on to the next one. All right, so next we are solving an inequality with some algebra. So we'll start with our -5 here. Now this 2 needs to be distributed out, so I'm going to do that. That's going to make a -10w. And then it's going to make a +14 because I'm going to multiply 2 by both those terms. And since I'm doing the positive times the negative, that's going to make that -10w greater than or equal to -5w minus 10 plus 7. So there's going to be my inequality. Now I'm going to start combining terms. I got a -5, +14. That's going to make a +9. And I got a -10, +7 will make a -3. So I got a -5w and that I said was a -3. Now we'll continue. We'll get our numbers on the same side. So if I have a -3 here, I'm going to add that over to make a 12. And then if I have a -10W, I'm going to add that over. That's going to make a 5W. So we'll add 10W over, add 10W over, and that's going to make a 5W minus. Oops, I already got rid of that -3 there. We added that over, excuse me. And then lastly, we'll divide both sides by 5. Divide both sides by 5. So I'm going to get 12/5 is greater than or equal to W. And I'll have to kind of think about that backwards here. I've got my W's on the less than side, so I'd have W is less than or equal to 12/5. So that should be my result. So I'll hit submit. And it'll walk us through a problem, and there we get our result where we get our 12/5. All right, one other thing that Delta Math has now, and we will continue to use this so that you guys can get your instant feedback, know if you did it correctly or incorrectly, is you'll get your problem worked out, but then you also can click on this watch help video, and it'll present a little video that'll go through the problem. I've seen the videos anywhere from a minute to maybe 5 minutes, but you can kind of skip around so you can kind of see a problem worked out as well. Makes it a little easier so you don't have to go back and figure out where our videos are. You can just click on that and see a problem presented, an example, and work it out. All right, well, that brings us to 7:45. So if you have those two done, I will go in and I will check, and you will get we'll get 1 point today, and then tomorrow we'll work on this some more, and you can earn some more extra credit, but you can get that 1 point today. If you want to stick around, I'll keep working through problems, and you can keep getting your extra credit. But at 7:45, you can go off and you can work on your own. I will be on here until 8:10. And if you want to stick around, I'll just keep working through problems on the review, and you can keep earning your extra credit. So if you are good to go, you can work individually, or you can stick around for more extra credit. Hold on, I'm just going to grab my headphones here. My speaker is kind of bad. Damien, I think your speaker is on. Oh, well, we can hear your video there, so you can just mute when you're not talking. Awesome. Looks like we're starting to get some done there. All right, so we'll continue. At any time, just interrupt me. No worries. And if something's not making sense, let me know. All right, so we'll head into next our proportional reasoning. And says our person Sophie is going to drive 189 miles in 7 hours. So when we have that miles and hours, we're going to start to be able to figure out her miles per hour. And if she continued at the same rate, how long would it take to travel 216 miles? So a couple ways that we could attack this. First, we could set up a ratio. We could set up that she's traveling 189 miles in 7 hours. So then we're doing miles compared to hours. We could set up 216 compared to X hours. And then we could use our calculator to do cross multiply and divide. So I take 216 times 7, divide by 189, and we'd get 8. So we can get X equals 8 using a proportion. So that's one way that we could solve this one. Another way is we could figure out her miles per hour. We could take 189, divide by 7, and that would tell us how many miles she can go each hour, which she's only going 27 miles per hour. And then we could use that and take 216 divided by 27, and that's also going to give us then our result of 8 hours. So you can look at it either way. This is your rate that you're finding first and then dividing that in, or we could set up our proportion. This is how we did it when we looked at this one in lesson 8. So this one is from lesson 8 if you want to go back and check that out. But either way, we're going to get 8 for our answer. All right, so it's not letting me check. That's all right. I'll just close that. Okay, well, I'm going to have to probably try that one again. Okay, it's getting a little mad at me, so let me re-log in here. So I can't have two windows open. That's good to know. Okay. But anyway, 8 was hopefully the correct answer. We'll see if we can get it. We got a different one. But I'm going to move on. I'm not going to waste your time anymore, but we'd be able to get 8 for that one. Next up, we've got our inverse variation. So inverse variation we looked at back in lesson 12. And inverse variation, we find our constant in a little bit different way. Our constant we're going to find by taking our two variables, multiply them together. We used y and x. Here they're going to use p and q. So either way, we are going to use that to find our constant. And then our equation for inverse variation is always our constant divided by our x. So we used the example when we were talking about this in lesson 12 was like if you had a job with a certain amount of hours and you wanted to do that job. If you did it by yourself, let's say it took you 100 hours, you'd take 100 divided by 1. That's how many hours it would take you to do it. But if you invited a friend, it's 100 divided by 2, which is only going to take you 50 hours each. So you're going to take your constant, divide by your variable, and then that's going to give you that y. So here we go. We got p and q. Very inversely, when p is 21, q is 23. Determine q when p is equal to 7. So first thing we want to do is find our constant, which is going to be taking our p times our q, 21 times 23. And we'll take that, 21 times 23, which is 483. So that means our equation then is p equals 483 divided by q. So I'm just using this model up here, except our problems use p and q instead of x and y. But there I'm just using that same model. And then I'm going to take that and take 483, divide by, I'm thinking of this one backwards here. I'm going to put a 7 in for p is equal to 483 over q. And now I have to solve for q. Okay, so solving for q, since q, as we're doing 483 divided by q, I'm going to multiply both sides by q. So I'm going to have 7q equals 483. So multiply my left side by q, multiply my right side by q, and then we could divide both sides by 7. So 483 divided by 7 is going to give us our answer, which is 69. Okay. And they're going to give you an example too. They're going to use proportions, kind of a proportion style, so you can use that as well. And there's also a help video to kind of help you through that as well as you want to work through that. But either way, you're going to take P times Q in order to find the constant. And then once you know the constant, you can set up your own equation, and that equation can be used to solve any type of problem that you need. All right, let's get this one erased. And like I said, those of you sticking around, I will check your scores after this. And each one that you do while we are logged in here, and I've got my attendance going, so I know that you guys are here. Each one that you do while we're logged in here will be 1 point extra, or a half point extra credit. All right, conversions with dimension analysis. We want to convert 4 minutes into seconds. Okay, so we've got our problem 4 minutes. So when we do our dimension analysis, we start by writing our given information as a fraction. So we got 4 minutes over 1. So we just put it over 1 to make anything a fraction. And then we're going to multiply it by a conversion rate. And the conversion rate we're going to use is that 1 minute is equivalent to 60 seconds. Now we're going to write that conversion rate as a fraction, but we're going to write it a specific way to get our minutes to cancel out. We're going to put our seconds up in the numerator, and we're going to put our minutes down in the denominator so that those minutes are diagonal from each other, and they will then cancel out. After that, we will take our fraction, we will multiply our numerators, multiply our denominators, which ends up giving us 240 seconds. Now this one you could probably just do a little bit easier, just multiply by 60, which is ultimately what we're doing. But we want to get used to how this dimension analysis works, because we will start to do higher level rates, and if you are in chemistry, you'll start to see that dimension analysis quite a bit. So as you're converting maybe from the metric system to the customary system, you're going to have all types of different conversions, and you may have 4, 5, 6 different fractions as you're multiplying out. But here we're going to get 240. There's our result. We'll put 240, and there would be our answer. Okay. So it's showing me I'm not quite done with that one because I didn't do the second one, but we'll continue. Next, we'll look at evaluate expressions. Let's see where we're at. We're at 1, 2, 3, 4, 5, 6 of our sections, and we got 1, 2, 3, 4, 5 left for tomorrow. So this will be our last one that we'll take a look at today. So we've got what is the value of the expression below when y is 5 and z is 3. So when we evaluate expressions or functions, we're simply taking the value of the variable, and then we're going to substitute that in for that variable. So if I have a 10y minus 6z, I'm going to take 10 times 5. And then my z is 3, so minus 6 times 3. And it ends up being 50 minus 18, which will be 32. So my final answer then will be 32. And a little suggestion, I like to put parentheses around wherever I put a number in for a variable. I like to put little parentheses around it so I can kind of really see where that was. And then if there's any exponents or anything, my calculator will do the order of operations correctly on those types of problems. So we're going to leave it right there. So we've done 6 out of the 11 sections. I will head into Delta Math here in a second and check out your progress at about 8:10 there when we get to the end of class. But I have nothing more for today. Thanks for joining on the I Try, You Try. If there's any questions, if you want to stick around, we'll look back at any questions, but we're going to save those last 5 for class tomorrow. So we'll start off right where we left off there.